Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and/or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello once again, welcome and thank you for joining us for today's webinar brought to you by the Oxygen Alliance. My name is Asante Tisa and I'm a biomedical engineer for the Oxygen Alliance. I'm joining this call from Lilongwe, which is the capital city of Malawi, and I'm honored to be your host for this session. Before we dive in, I'd love to know where you're joining us from, so please take a moment to introduce yourself by simply typing in your name as well as your location in the chat. And if you'd love to receive exclusive communications from the Oxygen Alliance, feel free to drop in your email address in the chat as well. Now, before we begin, just a quick update on today's agenda. We had scheduled to have a webinar on low temperature sterilizers featuring Jasper Ayaye, who is a biomedical engineer from Kenya. But unfortunately, due to unforeseen circumstances, Jasper won't be joining us today. We sincerely apologize for this change and we appreciate your understanding. However, we are excited for what we have planned instead. So for today, we'll be hosting a live panel discussion featuring experienced biomedical engineers from across Africa and featuring you, the audience, as well. And together, we're going to dive into some of the common issues associated with autoclaves, and we're going to have an opportunity to share some of the troubleshooting tips as well as practical solutions based on the experiences that we have had as biomedical engineers working in various facilities. And so without further ado, we're going to dive into our conversation. But firstly, I would love our main panelists for this discussion to briefly introduce themselves. So for our main panelists, we have Engineer Humphrey Nyirenda, as well as Engineer Daniel Mutama. So I'm going to cross the floor over to Engineer Humphrey Nyirenda so that he gets introduce himself very briefly, and then from there we'll proceed. Thank you. So over to you, Engineer Humphrey Nyirenda. You're going to tell us a little bit of your background and what you do and from where you're joining us. Thank you. Over to you, Humphrey.
Hello. I hope you are able to hear me. As
Yes,
Asante has said, my name is Humphrey Albert Nyirenda. I'm a biomedical engineer from Malawi, and I'm joining you from Malawi in the district. As a biomedical engineer, I've worked in central hospitals across Malawi and also in district hospital. Currently, I'm at the district hospital, and also I've also worked with international organizations which are working in the health sector. Thank you very much.
Thank you so much, Humphrey, for that lovely introduction. And I'm going to cross over the floor now to Engineer Daniel. If you can hear me and if you're on this call, please briefly introduce yourself.
Hello, everyone. My name is Daniel from Kenya. I'm a biomedical engineer working at Kisumu County Hospital. I'm 26 years hands-on experience in all machines, all the technologies. So in this training or in this webinar, I will share tips. Thank you.
Sorry, Engineer Daniel, we have, it seems as if there's a lot of background noise. Could you please maybe change the position so that we can clearly hear you? If you're in a comfortable position, you can introduce yourself again, please.
You can give me a few minutes. 5 minutes.
Thank you so much, Humphrey and Daniel, for your introductions. And reaching this far, we're going to dive into our main discussion for today. And my co-host, Janet, will moderate this discussion. Over to you, Janet.
All right, thank you very much, everyone. We really appreciate the fact that you have joined the call today. So this discussion is actually open to everyone. If there are questions that you'd like to ask or even want to take based on your experience, you're free to do so. We're not limited to the engineers that we brought on the panel. Along the way, we might be joined by other cool engineers, Remy, Mushi, and Damian. So the moment they join us, you also see us posing some questions to them. So please, just want to have a live audience. If you have anything to say, you're always open to come on board. I've noted that Engineer Remy, you have joined the call. Can you just please introduce yourself, your name, where you're from, and what you do as a biomedical engineer? Over to you, Remy Moshi. Engineer Remy, if you can hear me, can you please just introduce yourself? I know you're one of the panelists today. All right. So once Remy comes back, or if he's able to speak, definitely he's going to introduce himself. But right now, let's just dive into our today's discussion. So the first thing that would like to just hear from the audience, I'll just give a platform to the audience to just share the challenges that they mostly face with these autoclaves. If you have anything that you have to say based on your experience you faced and what you did to fix that challenge or fix that problem, just raise your hand and I'll give you a chance to speak. But maybe if you're in a sport where you cannot speak, you can just type in the chart experience with these autoclaves. So over to you, the audience. If you have anything, the major challenge that associated with the maintenance of the autoclaves, the ones that you have faced, the ones that you have experienced, may you please just raise your hands and share with us. All right, maybe the engineers, the audience will come along the way, but then I'll just pause yes and this. Over to you. You can unmute yourself and speak, please. I've seen your hand. Just unmute and speak. Yes. I've seen your hand. May you just please unmute yourself and speak. Ambes. All right. Lloyd, I also saw your hand. Just raise your hand and speak.
All right. Thank you so much, Janet. And yeah, thank you for introducing this panel discussion. I would want to share one of the major challenges that are associated with the autoclaves in general, as according to the experience that I have had working in hospitals here in Malawi. So one of the things that I've actually noted is the problem of blown-out heating elements. So this has been one of the major challenges in this autoclave. So you find that most of the heating elements don't actually work for long. So it leads to the elements being blown out. So yeah, that's one of the major challenges that I have ever experienced with autoclaves in general. Yeah, so that's what I can actually share as well. I don't know what other people have actually experienced with these autoclaves as a challenge.
All right. Thank you very much, Lloyd, for that that experience that you've shared. And maybe just to pause this to Humphrey, Engineer Humphrey, I know you have a lot of experience working with autoclaves as well. In a scenario whereby we see an autoclave where we have issues with the elements, the heating elements, what would you advise an engineer to do? Is replacement the first thing that we just go into? You just replace, or there are some factors that will determine whether you really have to replace? And when you are replacing these heating elements, what actually do you consider? Over to you, Engineer Humphrey.
Thank you very much. One of the challenges that we usually face with the autoclave is really what my colleague has mentioned about the heating elements. So to answer the question, eventually those blown out heating elements has to be replaced, but we also have to do an analysis of the causative agent of the problem at hand. So in this case, like he has said, most of the cases that are encountered across Malawian hospitals about the autoclaves is the burning out of elements. So usually the burning out of elements is caused by actually two main causative agents, according to my experience so far. Of course, there are many, but I'll just share two. And one of it is the power fluctuation. So in areas where we are facing or we are having power surges or power fluctuations, this has got an impact on the heating element lifespan and also efficiency and its effectiveness. So the areas that frequently experience power outage are prone to the experiencing burning out of heating elements. And one of the another cause of such instances is the water quality. So the water quality is one of the environmental factor which is affecting the autoclave. By water quality, we have areas in Malawi and also I believe in other countries across Africa and elsewhere where the water sources are salty or they have impurities. So in areas which are having such kind of water, which is normally called hard water, when you use that, it causes scaling in the steam generator, and also the salt that is in the water also facilitates the oxidation on the coating of the element, which also affects the effectiveness of the element. So you actually face issues like temperatures declining, you're having fluctuation in the temperature, sterilization temperature, or the pressure is not building up in the chamber or either in the jacket. So these are the main major causes of element issues. In Malawi, we have countries like Kalonga, where we have salty water, and also other countries where they have salty water. So the hard substances or the hardness of the water is main cause of element issues in such areas. And to mitigate that one, we have to treat the water. So you can either use osmosis treatment or what we call deionized water treatment, where you use chemicals to remove the chlorine and the other ion, including the cations from the water, so you can use it. Sometimes you can also use distilled water, but this is mainly used for the tabletop autoclaves. But for the vertical autoclave, which are front load, like the Shiva, TKR, these ones you can use what we call deionizing treatment. Osmosis, I know osmosis is a bit expensive, but it depends upon the funds that are there. But these are the solutions that we can have to mitigate the actual causes of the problem at hand, which are the hardness of water and also power fluctuations. So for the power fluctuations, we would use voltage stabilizers. So you can opt to connect your autoclave through the voltage stabilizer so that you should sustain a continuous and undisturbed power supply to the machine at hand. Thank you very much.
Thank you very much, Engineer. For that. Thank you very much, Engineer. For that. I think a lot of comments. I think a lot of comments is that a lot of people have gone through. A lot of people have gone through. Other had Engineer Humphrey. Just please unmute yourself. Just please unmute yourself. Mute yourself and come back. Thank you very much. So, Daniel, yes, Daniel, you've raised the hand. Over to you. I hope you're in a very good spot now. And what
So thank you very much. Sorry, I was in a noisy place. I was just connecting from another hospital to another hospital for the service of the lab machines, but now I'm a bit settled. I just wanted to add about what the engineer said, the challenges you can get with the electric heating element is the replacement of the electric heating element, the immersion type. You find that the electric heating element is rated 2 kilowatts. And then during the replacement, sometimes back I replaced 1.5 kilowatts. The heating was low, and that one gave me a lot of challenge, only to notice that after some time that I replaced a low rated electric heating element. Another, so in that line, when our engineers are replacing the element, it is very important to check the wattage of that particular electric heating element. Also, the numbers of the electric heating element, if there are 2, you should replace 2. If there are 3, you should replace 3. That's depending. If there are 3 and the autoclave has a low heating, and you find that these elements have worked for a longer period of time, you should not replace 2 and you leave 1. You should replace all of them at the same time. Another challenge is when you are replacing that electric heating element, you find that element has that diameter where you are placing through that autoclave. Sometimes that diameter is a bit smaller. So when you fix it at the autoclave, you get leakage. So it is very important as an engineer that when you are replacing the element, you need to take care of the diameter of the where you are putting back the gland nut. That area, that metallic part, you need to put what we call the Teflon thread, and then after that, you run through using your hand to the direction, to the clockwise direction. At that point, after you have put that Teflon thread, that is the time now you put the gland nut. That will ensure there will be no leakage. But there before, I used to put the element. I don't put enough Teflon thread. When you start hitting the autoclave, there are leakages. So when we are repairing that, as an engineer, that is very important for us to check.
Thank you very much. Thank you very much, Engineer Daniel. I've seen Engineer Good and Engineer Remy in the house. So may you just please unmute yourself and introduce yourself as well. Engineer Good, just introduce yourself, a bit of the background of who you are, where you're working. Thank you. Engineer Good, if you can hear me, just introduce yourself. Engineer Remy, you can also do the same thing. Yes, Remy, you're...
Hello, good afternoon. My name is Remy
Afternoon.
from KSMC Hospital.
All right. We need to have you there. Sure that your mic is on point, you're in a good spot, so that when we pose these questions to you, our panel. So for engineering me, I think we can do this. That you're not in a very good spot. So moving forward, just read some few comments that are in Andes gave us a comment to say for it looks like her mic is not going on well. So she's a biomedical engineering student in Cameroon. And she's saying, I've had some experience with autoclaves in my internship. The challenge I faced is shocking on my body of the autoclave, overheating, and also very high pressures. So she mentioned shocking on the body of the autoclaves, overheating, and also high pressures. For high pressures, we didn't get to check because the autoclave exploded in the theater. For the shock, it was loose contact touching the body of the autoclaves. I can't really talk much about the overheating and the pressure that caused the explosion. I would love if we could discuss about the possible causes. So I'm posing this to our engineers. This is a student who went through an internship and then she experienced an explosion of the autoclave. She went through shock, there was also high pressures and overheating. So she just wants to understand what could have been the possible causes of this scenario. I will pose it to you, Engineer Goat, if you're here. Please just unmute yourself and speak. If you can have a say on what happened, this whole scenario, what could have been the possible causes? If at all the engineers out there need to avoid something, what is it that they need to avoid? All right, as we're waiting for Good to speak, may I also pose it back to Humphrey. Humphrey, maybe you have any idea of this, or what approach can somebody take, or what could have been the possible causes of this? Thank you.
Thank you very much. So from the explanation that she has given, according to her experience, it is quite evident that the autoclave had an issue with the relief valve. Normally, the program modules are given different programs which comes with preset pressure, temperature, according to that sterilization program that you've chosen. But in instances where the control system is faulty or is experiencing some flaws, that might be caused due to maybe power fluctuations or other things or shortings. What happens is the program goes haywire, and what normally happens, then the pressure has to increase. So you find out maybe the pressure in the jacket is just building up. Maybe you set it to 110 kPa, but it goes beyond that. So within the system itself, the design system itself of the autoclave is embedded with the relief valve. And when the pressure is above the normal set range, the relief valve had to open. So in a scenario where it's obvious that the relief valve did not open, one of the cause of the relief valve blockages is impurities within the system. So according to the manual or the manufacturer's guideline, there are some of the general cleaning that has to be done either monthly or annually on the autoclave. I earlier on talked of scaling that is caused due to hard water. So when this scaling is built up in the steam generator, what happens is it blocks it goes even beyond in the pipeline system or for the drainage system or other openings between the jacket and the chamber or the steam generator and the jacket. So when these debris get into the relief valve, they block those valves. It might be maybe relief valves or other valves, but in her case, it's obviously the relief valve. So it got blocked, and then the pressure was just going up. So the chamber are made or are given a certain range of the maximum pressure. So in our case, it means the pressure went beyond the manufacturer's limit due to the 40 relief valves. And on the part where she says she experienced some shocks, that has to do with the electrical systems, the connection systems. So normally autoclaves are powered. Some of the autoclaves are powered with three-phase power, where you connect either in delta or star connection. So the star connection uses a neutral, but the delta you can just use live wires. But in star you have three-phase connected to a central neutral. So when the power is going into the elements, it has to return to the neutral. So the neutral serves as a return path for the voltage or for the current that is flowing in the wire. But the whole system has to be earthed as well. So when there is an issue with the earthing, and you have an instance where this one of the live wire or the earth or the neutral wire is touching the chassis of the equipment, so it means the whole equipment will be carrying a voltage or will be carrying a power, and then when somebody touches it, it creates a path which throw resistance. So the current has to flow through her body. So that's how she experienced shock. So that is an indication with the issue or the fault with the electrical system. Either the earthing is not collectory or there is touching elsewhere with the live wire or the neutral wire with the chassis of the equipment at hand. Thank you very much. That's what I can say.
Thank you very much for that well elaborated explanation to this scenario. Yes, Lloyd.
So I just want to add on what Engineer Hafra has said as well. So in one of the days we were working with the autoclaves, we are experiencing the same thing, and it was actually a 40 element that was causing this because it had a small burst inside the boiler, so it was like shorting the whole autoclave. So whenever you touch it, you're experiencing like a shock. So that is one of the other causes for this shocking. Yeah, thank you.
Thank you so much, Engineer Lloyd. And now, yes, Daniel, I know you have raised the hand, but also need to move to the other questions. But I'll just give you a chance to speak for like some seconds. Yeah, over to you, Daniel. Yes, Engineer Daniel, you raised the hand. Over to you before we move to the next question.
Can I continue?
Yes.
Thank you. Thank you.
Continue.
Thank you. This is brought by overpressure issue. Is brought by a user will leave the equipment unattended. He or she will switch on the equipment and then he leaves it working. You will find that the equipment will continue heating, and at that point it can lead to overpressure issue. Engineer has talked about the safety valve. Sometimes that safety valve there is interference. It can be a user interference, it can be a technical interference. When you take it, it has a seal, but sometimes our technicians or the users, they interfere with that seal. When the equipment is working and that safety valve has been interfered with, there is likelihood of any pressure coming out. When the user is closing the lid, the closing is not uniform. You'll find that the wing nuts have to be closed, two opposite wing nuts at the same time, if it's a vertical autoclave. If that closing is not even and you find the lid is loose, that overpressure can cause that excess pressure coming out. Maybe if there was a replacement of the safety valve and the correct technical specifications were not followed, that can lead the safety valve explosion. I think those are some of the points I had for overpressure of the unit. Thank you.
Thank you very much. Right now we'll have to also go through a discussion on what are some of the maintenance mistakes that we make as engineers when we're working with these autoclaves. It can either be us working on them, or it can even be the attendant. I know in some hospitals we have people who are responsible for loading and unloading the sterilized items. So we just also want to discuss about the mistakes. Maybe if it's you who does that, this is a time that we need to learn from each other. The floor is open for the whole audience. If you have an idea or if you have anything that you'd like to say, just raise your hand or you can type your comment in the chat. So I know, Engineer Remy, you said you're in transit and you cannot be able to respond. You'll just be typing in the chat. Thank you very much. We'll be reading your comments there. So I'll pause this to the audience. Just if you know any mistake that most engineers do when they're working with autoclaves, just raise your hand and bring it forward. But we have seen your comments, we are reading them, and thank you very much. You can keep those comments coming. All right, Engineer Danny, you're unmuted. Over to you if you have anything to say about the most common mistakes that we make when we are maintaining these autoclaves.
One of the common mistakes we make when we are maintaining the autoclaves, number one is as a technical officer, we don't understand the user operation or how the procedure of operating the autoclave. The procedure of operating the autoclave, before any engineer works on that particular autoclave, it's very important you know the procedure of operation. And when sometimes what we call the quick guide is placed just beside the face of the equipment for the technical person to be able to follow. That is, let's say you have repaired the equipment and you would want to run that equipment. Another mistake we make while we are repairing the autoclave, let's say this autoclave is connected to the compressed air. We don't drain the condensate from the compressor. You will find that if you don't drain that condensate for 2 weeks, there is a lot of condensate, there is a lot of water formation, and that water formation will interfere with the pneumatic valve. So as a technical engineer, we make a lot of mistakes by not considering the release of the condensate. The other mistake we have is we don't grease the wing nut. The wing nut, if it is, for example, the vertical autoclave, we need to use what we call the silicone grease. Sparingly, after some 2 or 3 months, sparingly, we need to grease the wing nuts. Most of our technical people, we don't grease the wing nuts. The other issue we make a mistake is cleaning of the equipment. You'll find that the equipment is working, but the equipment is dirty. As an engineer, as a technical person, before you start working on that equipment, first, we need to disinfect the equipment.
Yes, Engineer Daniel, we lost you for a bit.
Those are some of the problems.
You sound like you're very far from your mic, but I think I got you. Thank you very much for those shared mistakes that are made when working with autoclaves. I saw a hand from Engineer Humphrey. May you just unmute yourself and speak.
Hello. So one of other mistake that we make as we're maintaining these autoclaves is the idea of once it works, leave it working and don't tamper with it. And so that brings in negligence in conducting some of the preventive maintenance, where you have people questioning or the user questioning why do you want to see this machine if it's just working as is intended to be working. So negligence of sometimes doing what we call the maintenance guidelines, as I mentioned, where maybe the manufacturer may specify that it has to be cleaned after 3 months due to some debris that sometimes occur in these systems. I'm saying this because here at the district hospital, we had an autoclave which was down, and upon inspection, what was observed is this autoclave has stayed quite long without carrying or performing the recommended cleaning stages that were specified by the manufacturers. So we had issues like the system starting up and maybe not passing the passation stage or not even going to the heating stage, getting stuck at a certain stage or a certain level within the process. So one of the main cause of such instances is a negligence of doing some cleanings within the machine, considering that the machine is partly electrical and partly the water systems, the valves, these sometimes they clog. So cleaning is quite necessary, and we don't have to ignore that guideline. Another one of the other mistake is assuming the user is well conversant with the machine. So in those instances,
Engineer Humphrey, we can't hear you. We just lost you for like a moment. All right. But that was a good point. I really like the point of assuming that the user knows how to operate the machine. There are just some comments in the chat. I'll just read them. There was an experience that has been shared by Lavo Miseo. He's saying, I usually experience an issue with our autoclaves where the chamber pressure continually builds up during operation, but the cycle does not proceed to the heating stage. The machine remains in the pressurizing or pacing phase, preventing the sterilization process from continuing. The pressure taking issue disrupts the normal operation of the efficiency of the autoclaves. And I've seen a response from Engineer Remy to say, Lavmo, you should check with the pressure sensor, depending on the nature of the sensor being used for scaling, complete blockage, and set the value of the pressure to be attained for it to go to the next phase. In some circumstances, the spring strain gets reduced over time, in which it fails to respond linearly to the active situation inside the chamber, in which you are forced to change the whole sensor compartment. So that was a question that Lovemore posed in the chart, and Engineer Remy, thank you for answering that question. Now, looking at the fact that you said we should be he's supposed to replace the whole sensor. Now, what are the common frequently replaced parts in autoclaves? I know one of them is the heating elements, which we have already talked about. But then can we also discuss other parts that we need to replace? And when we're replacing those parts, what are we supposed to do? Is it just getting it and putting it there? What are we supposed to consider? Is it the same as we were saying for the heating elements, of which I don't think it's the same? So I'll just pose this to the audience. If you have anything to say about the parts that are mostly replaced, based on your experience, maybe you can just share what are the parts that you have tried to replace once, and what did you do? So I know there's Bakari Gataya. If you have anything to say, please just unmute yourself and speak. All right. Yes, Daniel. Over to you, Daniel. You raised the hand.
Thank you. If it is a vertical autoclave, there are different parts mostly replaced. One is the valve, the control valve, and two, it is the safety valve. The control valve and the gaskets who are within the valves, sometimes they wear out, they are replaced. Another part which is replaced is the overpressure plug. That plug, sometimes it can escape by itself. That part is that knob, after some time it is replaced. Another part you replace in the vertical autoclave, it is the miniature circuit breaker, the one which is written C25 or C40 or C45. That one sometimes it is replaced when it is faulty. The wing nuts, sometimes they get the threads, they wear out. So when they wear out and you are trying to close and they are not able to close, you are able to replace it. Other times you can replace the gasket if it is torn or is cut. So generally, any spare, those are the main parts within the vertical autoclave who are mostly replaced. Thank you.
Thank you very much for that response. Engineer Good, I don't know if you're in a very good spot to speak now. Maybe if you have also something to say, may you just please unmute yourself and speak. All right. So I know there are a couple of comments in the chart. good like you are asking a question. If the autoclave element is working and the circuit or regulator is not working and you can't get a replacement, what do? There's that question in the chart. If the autoclave element is working and the circuit or regulator, of course there's regulator, I don't know if it's regulator or regulator, is not working, and you get a replacement. From Goodluck Oboro from Nigeria. I don't know any of the engineers, if you can be able to take this question. Engineer Hamfley, can you take the question? Or Engineer Daniel, Engineer Remy, if you have an answer, you can just type it in the chat. Yes, Daniel.
Thank you. The electric heating element is connected from the miniature circuit breaker. Then from the miniature circuit breaker is connected to the contactor. From the contactor, it is connected to the electric heating element. If the miniature circuit breaker is faulty, let's say it is C45, replace with the same rating, C45 3-pole. If the contactor is faulty, maybe it's single facing. Single facing means one line is not passing through. Replace that contactor with the same rating. Is it C25? Is it C40? Replace with the same contactor. So it will not be allowed to connect the electric heating element directly without the MCB, without the contactor. So if any of the two, they are faulty, you must replace with the same rating. Thank you.
All right, thank you very much. So I know we talked about the replacement of the elements, but one of the questions that we really wanted to be clear on was how do you properly install or replace the heating elements? These ones are the ones specifically for the ones that use the three-phase. We know there's a bit of delta connection, there are others that are supposed to be in star. So we just want to really understand. Based on experience, I've had a scenario to see you just replace an element today, you try to turn on the auto, then it's not working because of how you have connected. So we just want to help each other as engineers. How well do we connect these elements? So if there's anyone to answer, I know Hamfley, you started talking about this, but maybe you didn't finish. If you have anything to say about proper connections when it comes to heating elements, please unmute yourself and speak. I can see Peter Kanyika, you're here. Have anything to say on this? You're also free to speak. Over to you, Daniel Utama.
Hello.
Thank you.
You're back. So let's just allow Daniel to speak and then you come after him. Continue, Daniel.
Thank you. The issues of connecting the electric heating element in machine type, if a set means it's one holder inside with two elements. So if it has two elements, you can connect with two lives, and then the other one you can connect to neutral. If one set has three elements, you can share every line one to supply one element, line two to supply another element, line three to supply another element. The neutrals, you short them together. That means you balance the three lines. If the electric heating elements are two sets, let's say there is one holder with three elements and there is another holder with three elements, and the total elements are 6. It means you will short two terminals of two elements and supply with live. You also short another two terminals of two different elements and you supply with yellow line. Then you also connect two terminals of electric heating element and you supply with blue line. At that time, you have balanced the phases. The other remaining terminals of the elements, you interconnect them, all of them, and you supply the neutral connection. That's how you supply the electric heating element. And that's how you balance the three-phase supply system.
Thank you very much. Thank you very much, Engineer Daniel. Over to you, Hamfley. On that. Engineer Hamfley, if you're speaking, you're on mute. Engineer Hamfley, if you're speaking, you're on mute.
Hello.
Yes, we can hear you.
Can you hear me right now?
Yes, we can hear you.
Yeah. So what I'll do, I'll just give an overview on the different connections that you may find with your autoclave. So normally we have star and delta connection. There are a few differences between them. in delta connection, the configuration where you have three phases is usually connected in each heating element is connected between two phases. So you can use two phases to you make sure that each element is fed with two phases with the delta connection, because in the delta connection we don't use the neutral. So normally when you've seen the system that is using a delta connection, that implies that the system actually requires more generates a lot of heat or requires more power, and with those systems you shouldn't swap to connect in star connection where you involve a neutral. So the setup is usually ideal for high power applications. So you have to note with your autoclave whether it is in delta connection or star connection. With the star connection, it is as my colleague has explained, where you feed each, let's say you have three elements. So you feed each line of these three elements with a single phase with three phases, and then you feed the remaining part as which is supposed to receive a neutral by a single neutral, like in the way that you explained that you just showed them, feeding them a single neutral with a star connection. But with the delta, you just use the live or wires only. So what happens is you have three elements, and each side of an element is receiving a phase, not from the same line, from the same phase, but from different phases. So you may say element 1, element 2, element 3, where element 1 is having AB as the connection terminals. So you may use phase 1 to connect the A's of element 1 and element 2. Then you use the phase 2 to connect the terminal connections of element 3 and element 2, and then you use the remaining phase to connect the elements of the terminal element of element 3 and element 1. So it's like you in that case you have achieved feeding each element with two phases. So that's what happens. But normally the difference is the delta is meant for the systems which are requiring high power, and the star connection usually requires low powers, where you have to do your sterilization temperature or your sterilization pressure are minimal. So star works, but with the delta, it requires those systems which require a lot of temperature and pressure. So that's the difference that I may elaborate.
Thank you very much, our engineers, for so reaching this far. I would like to take it back to the host. Thank you very much. This is the discussion that I wanted us to have. But then there's only one last part that is remaining before we close the call. So at this point, I'll hand it over to our host. Over to you, Asante. Thank you very much, our audience.
Thank you so much, Janet. I believe this has been a very insightful discussion for each one of us. And I believe so much has been shared, and we have gained the practical knowledge that we will need in as far as handling these autoclaves is concerned. Special thanks once again to our panelists and my co-host Janet, as well as everyone who has contributed in this call. So this happens to be the last session for the Sterilization Webinar Series. And like Janet said, we would love to get feedback from our audience on their experience engaging in this webinar series, and also just to share a little bit on what they think would have been done better and how they want us to improve moving forward. So I'm going to open the floor to two volunteers. You can raise your hand and I'll open the floor to you so that you can simply just share your experience in as far as engaging in this webinar series has been for you. So I'm opening the floor to the audience. Thank you. All right, good luck. You can unmute your mic and share your feedback.
Okay, the training has been okay, very successful and very insightful. I think we'll need more of it, more refresher courses like this to, keep us, interact with modern realities. I just want to add something. I think my own experience personally, we have one dry steam autoclave in our facility, and the control elements later went bad. And what we call an engineer that came to look at it and he kind of improvised, got a timer and a timer relay or something, and did the connection, and that was what we have been using. So I was thinking that probably something like that could have been shared, probably when you don't really have the parts to work on them, so that you can actually improvise, maybe using other sources, other means to ensure that the autoclave works. So most biomedical engineers, most times we don't get the knowledge or the time to be trained. Most times these are the only avenues we have for us to actually be trained. And so that was why I was asking, in case you have an autoclave that is not working, and you need to make it work. Meanwhile, you don't have the available parts. What do you do, kind of? So I was just speaking based on my personal experience and knowledge. Thank you.
All right, thank you so much. Good luck for that feedback. I'm glad to hear that this has been a very insightful series for you. And I believe that as you have many questions going forward, you can always contact us so that those questions will be addressed. I'll ask one more volunteer from the audience to share their feedback, and we'll proceed to close the webinar for today. So one last person, please. Engineer Love Momiseo, would you like to share anything? Or anyone else in the audience, you can raise your hand and then you unmute and go ahead and give your feedback. All right, Daniel, you can unmute and speak.
Thank you. I only wanted to answer that engineer that is not able to get the spares. But in engineering, we say what you can buy, don't make. So get the spares from the shops. And also it's very important for this group, we create a WhatsApp group. When somebody has a technical question, we can answer. We can also answer where one can get spares. Thank you.
All right, thank you very much, Engineer Daniel, for that comment. I know for some who do not know, when it comes to the questions, asking questions and getting answers, we have the BME Conta app that is there for you. If you have any question, any engineer across the continent can answer your question, can also help you in getting the spares, or maybe just advising you on how you can go about your current problem. So if you don't have access to the app, you can download it from Google Play Store. It is called the BME Conta app. Thank you. Over to you, host.
Thank you, Janet, once again. So that brings us to the end of today's webinar. A heartfelt thank you for our panelists for their valuable contributions, and to each one of you for being part of this insightful and live discussion. And if you have follow-up questions, feedback, and would like to stay connected, please reach out to us at info@oxygenalliance.org. And like I said, this is the end of our sterilization equipment webinar series, and we'll be moving to another series. So just be on the lookout for more details coming to you soon. Until next time, you are with me, Asante and Janet. This is a goodbye for now. Thank you.
Thank you.